So we are taking excess heat and we are keeping it, and we will provide it back to the plant at 3 p.m. Thus, we were saving all the gas that will go to waste. Also, we will enable the plant to provide grid balancing to its own assets, the Enel assets, for example, at night. So in the future, they will be able to provide themselves grid balancing services to their wind farms.
Today on the Clean Power Hour, decarbonizing thermal energy storage for industrial and grid applications. I'm Tim Montague, your host. Today on the Clean Power Hour, my guest today is Nir Brenmiller. He is the COO of Brenmiller Energy, and they have a very interesting technology that is replacing fossil assets, both for industrial and grid applications. I want to encourage you, my listeners, to check out all of our content at cleanpowerhour.com. Please subscribe to the YouTube channel. Just go to cleanpowerhour.com, hit the YouTube icon, and subscribe to the show. Please give us a rating and review on Apple and Spotify. That is how other people will find this content. With that, welcome to the show, Nir Brenmiller.
Thank you, Tim. Thank you for having me.
I'm on a tear with thermal energy guests on the show. I'm super psyched. I think this is a very, very important topic and one that all energy professionals need to be more versed in. We feel very good about ourselves in the photovoltaic industry because you're making electrons from photons. It is a very clean process, but there are many other things going on in the world that require decarbonization, and we have to get serious about a huge portion of our carbon footprint. Industrial applications, all said, are upwards of 25% of our carbon footprint. So give our listeners a little background on yourself and the company, and then we'll dive into the story of Brenmiller Energy and what you guys are up to.
Well, thank you. So I'm the COO of the company. We founded the company, my father, my brother, and myself, more than 10 years ago. We are coming from thermal solar. We had vast experience building, designing, operating thermal solar power plants. And we saw all the issues with intermittency, with providing, the power when the sun is not shining. And then it was clear to us, in order to go to the next stage, we need to develop simple, low-cost storage. And we really didn't like molten salts because they were too heavy on operational and only affordable in huge scales. And we developed this thermal storage which heats up rocks, and then we take out the heat from the rocks by running water or hot air through the system and discharging it. We are charging the system with either heat, power, electricity, or biomass, or hybrid. And we are charging the system all the way to 750 degrees C. We can discharge it at 550 C, but also all the range below. And then we realized that what we have developed for thermal solar is actually a solution for so many applications, grid applications for power plants, gas-fired, coal-fired power plants, industrial heat. We saw our core competence providing heat to industrial processes. You mentioned that it's the single largest source of energy, industrial heat. And then right next to it, you can also find district heating, a huge source of energy. And as you mentioned, we are often think about PV or wind as the target, but these are just, these are just technologies that's supposed to bring us to carbon neutrality or carbon zero. And then you have to look where the carbon is coming from. And you see so many ways and so many applications that you need to provide. And these are just a small portion. Electricity, direct electricity, we need to take care of transportation. But what we do is we take care of industrial heat. We take care of heating at district heating. And we support power plants to be more flexible and be able to shut down when you have enough wind power, when you have enough solar on your grid. So I will tell you a little secret that okay, you can have a very nice day in California, the wind is blowing and the sun is shining, but then you need to go to your coal-fired power plant. You don't have many of these in California, not a bit good example, but gas-fired power plant, and see, did they shut down? Well, they did not, because they have to ramp up very fast at 3 p.m. and they cannot go up and down, in minutes or even in few hours. So what they do is they go down a little bit, and and they still burn gas, they still pollute, they still create carbon, and we did nothing because we are paying for the electricity for these power plants to be on standby, to be available, and then we are paying for the PV, we are paying for the wind. So our peak prices are surging, and in parallel, we did not cut emissions because we don't have this storage or we don't have the technological mean to really shut down these power plants, to tell them go all the way down, don't go to 60%, don't go to 70%, go all the way down, we don't need you, and when we will need you, we will give you a heads up. So this is what we do. We on the industrial scale, we can actually replace boilers. We connect the intermittency of the electricity coming from PV or wind or biomass source, and then we provide heat to our customers on demand according to the customer's demand. And in power plants, we enable the power plants to ramp up and shut down very fast, and to streamline all the excess heat directly to our storage and be much more effective both on gas burning and on operation. And by doing that, we actually enable more renewables into the grid because these power plants can react.
So there's really two major applications of your technology. One is industrial heat, and I want to take a deeper dive into that. You can imagine you're making plastic products, or you're making steel, or you're making glass, or you're making food. There are many, many industrial applications where we need lots of heat, and today we're using lots of natural gas primarily, but all kinds of fossil fuels, oil, coal, etc. And then there's the power plant side of the equation. We have peaker plants running on natural gas, and those are very on-off technologies. They're there specifically to meet peak demands in high load times of the year, like a hot summer day. And those assets are running at a very high cost because they are just running part-time, not 24/7. And your technology allows for power plant owners to decarbonize that process and include a significant storage component, which I want to get into. I mean, you can think of fossil fuels as storage, and now we're going to replace some of those fossil fuels with hot rocks that are then heated up with either biomass or very cheap grid power from excess wind and solar. And the other comment I want to make at the outset here is that when you get high penetration of renewables on a grid like we have in California today, that is really the only, California and Hawaii are the two markets where we have high penetration now. And the reality is that the grid load overall is not highest when solar is peaking at the middle of the day. Grid load is highest in the afternoon when solar is waning. And so there's a mismatch. And so if you could take that extra solar energy and store it in thermal energy, in a thermal battery, basically, or any kind of a battery, of course, there's other types of batteries, but thermal batteries are just one way. And then you have power when you need it at some later time, and it pairs very, very nicely with renewable energy. So let's take a deeper dive into the industrial side. You sent me a story this morning from Yahoo about Fortlev, which I understand is uh, a water company, but a water technology company, but they make
They
big
produce
plastic
water
tubs,
tanks.
right?
Yeah, yeah.
So
So
what's
Fortlev,
that story? What's the exciting news? And then let's just geek out a little bit on industrial applications and let's focus on, if you own an industrial facility, how Brenmiller can solve your carbon problem.
well, usually you have boilers. These boilers run, the main source in the world, by the way, is coal, followed by natural gas and other fuels. And what we enable you to do is to buy, or if you have a solar field, or if you have access to biomass, charge our system with these sources when you have them available. Now you can have a couple of sources. You can have either low-cost grid power at night. In Eastern Europe, for example, you have a lot of curtailed wind at night. Now you can provide grid services. You can get paid at night to curtail wind off the grid. And I'm talking about very big numbers. Some countries you have 20-30% of curtailed wind at night. And then you are getting paid at night to provide grid balancing. And the nice thing about the thermal storage is the capacity. You have the ability to take a lot of power off the grid in a very fast response time, not milliseconds like batteries, but you don't need milliseconds when you are doing grid balancing. And then we can use this heat tomorrow to provide clean water, steam, hot air. And what we are doing in Fortlev, for example, Fortlev is in Brazil. It's a huge company that the main product there is water tanks. You have a lot of water tanks in South America for industrial uses and for houses. Now, you use a lot of heat to melt down the plastic, and it's a batchy process. So you have peaks, and these peaks, let's say one machine, they have over 60 machines. Each machine, for example, have 4 megawatt peak and around half a megawatt average consumption. Mm-hmm. So when you are using natural gas, and they're using liquid natural gas, and the prices in Brazil are very high, by the way, not just because of the volatility, but also because of the distances. It's a continent. And to move gas for thousands of miles is pricey. And now when you have a burner which is not very flexible, then you are burning close to the peak, and then your efficiency is low because your average consumption is somewhere around 1/10 of the peak. What we are able to provide is the flexibility to follow the demand curve using our system. And then you can charge it only with the average consumption. So the burners go out and burn biomass. It's local sourced biomass. So it's a circular economy. You're taking this biomass off the landfill or off the forest. The main issue with global warming today is methane. You want to take out as much as you can from landfills, from forests that go. All this forest waste goes to rot and generate methane gases. So we are using local sourced biomass. We are burning the average, and we are bringing the efficiency from around 20% to 80% cycle efficiency. And bottom line, we are cutting the cost dramatically for the power plant and reducing green gas house emissions. And many people tell me, Brazil, they don't follow the code, they don't really care about the environment. But what's going on today with ESG and third tier calculation of your emissions? So people are going all the way, and corporates going all the way to the supply chain and to the end suppliers, and these suppliers become aware very fast on their emissions, regardless if the country they are coming from is yes or not aware to or take action on fighting global warming. So this is what we do for Fort Lev. We had the first system now officially commissioned. This is what you saw on Yahoo, and I'm sure many systems will follow up shortly because the savings is dramatic, and also the emissions. And this is the savings is before we calculate the value of emissions saved.
So you've done effectively a pilot with Fort Lev, and you are designing a much larger project with Fort Lev. Is that right?
No, it's a full-size project. It's just the first, and now we are multiplying it. We took care of one machine. They have over 60. Based on that project, we were able, by the way, to sign the contract with Philip Morris International, the tobacco company. They're huge producers of heat, and so we signed a framework agreement with their corporate, and under this framework, aiming to decarbonize their production plant, and they have many spread around globally. We have the first project in Romania, which will use biomass, again, local sourced biomass from agriculture sources that surrounds the factory. So we take this waste and turn it into fuel, low carbon fuel, because we are using all the European directive to stand in the emission cap that you got. And that's a very, very important tool, because biomass in many countries is 20 to 30% of the market in terms of industrial fuel. So if you take the efficiency, from 20% to 80%, it's quite a dramatic move. But we are also able, in the future projects, we are talking about full electrification. It really depends on the local sources, what you got in these local sites.
Yeah, and that's the goal, I think, that really we clean energy professionals aspire to is having a industrial heat ecosystem that runs on electricity, because it's so easy to generate clean electrons. Biofuels can be relatively environmentally friendly. It just depends. It's a mixed bag, and it's good, bad, ugly. So we don't want to be deforesting the planet, creating wood chips, and then replacing coal with wood chips from deforested land. That would be a bad thing, and that does happen. I'm not suggesting that in this case, but Nir, let's talk a little more about this customer of yours, because it's a very interesting company. Fort Lev is a plastics manufacturer, but they're also have a solar division called Fort Lev Solar.
True.
So they're very interested in renewable energy and in the environment, and so I'm just fascinated by this partnership that you've developed. I think it's a great story. And so if I just want to recap for our listeners, as I understand the system, today you have a boiler that's running on fossil fuels to generate industrial heat for this manufacturing process. Tomorrow, you've got a Brenmiller unit called a BGen, and the initial unit is a 1 megawatt hour unit. There's a much bigger project to 60x this. And when you do that, you're going to reduce the footprint of Fort Lev, their carbon footprint, by 48,000 metric tons of greenhouse gas emissions per year. That's equivalent to 10,500 internal combustion engine vehicles. So it's a big footprint. And I guess I'm curious, the before versus the after. Who is a good customer? Because these boilers obviously have a lifespan, and you need to find customers who are thinking about either expanding or in some way replacing their technology. So tell us a little more about this project and this opportunity, and then, if you would, to the extent that you understand it, what is Fort Lev Solar up to, and why are they interested in thermal storage?
I will divide the answer to three continents. I think that the situation in Europe, in the US, in Brazil, is the one global economy, but totally different. In Europe, it's a matter now of energy security. We have a lot of discussion with manufacturers in Europe that they are afraid that next year they're not going to have natural gas to run their boilers. So they are looking for alternatives, and we provide them a way to electrify their natural gas boilers. Now that's energy security. And then ROI is less of an issue because I'm going to run out of energy soon. And by the way, also district heating. For example, in Hungary, we have a couple of projects that we will provide green balancing at night, take curtailed wind power, and then provide district heating. I just saw a slide by the European Union released today. Over 60% of the energy in the EU goes to heating, space heating. These numbers are crazy. So most of the gas goes to space heating. We will provide hot water or steam to steam networks to replace the use of gas. And then ROI is less of an issue because you wanna do something with your energy crisis. In the US, I'm looking for companies that either have very specific ESG goals. We need to cut off our carbon footprint by X. And when you are going to a company that delivers a software, okay, they can replace the light bulbs and put LEDs and then they are okay. But when you are going to companies that manufacture something, 80% of your factory usually is heat. And if you're using natural gas, and that's the best case scenario when you're using natural gas, and you want to decarbonize it, you need to do something. You need to replace something, and we are enabling you to replace these. And with the current prices, our ROI is extremely fast. In Europe, by the way, we also have the carbon pricing, which we are still lagging behind in the US. But in Europe, we have two lines in our Excel: the direct savings from gas and another line of savings of carbon taxation credits, depend on the country that you operate in. So any factory corporate that is considered a corporate that needs to decarbonize, and we are doing it in most cases we are competitive to natural gas. And there are many locations that use fuels and other source of diesel fuels. So then, for sure, we are competitive. In Brazil, the cost of energy is just dramatically higher than in the US and Europe. And then your ROI is very fast. And Brazil is huge in heat. Brazil is as big as Europe, the whole European continent in heat. A lot of production, food production, materials, so they are eager to find, and also extremely distributed. So perfect for our solution. Fortlev and Fortlev Solar are very aggressive and a great partner. We are now in the design stage of building the second factory of our company in Brazil. It will be owned by Fortlev. And then we can be very aggressive on marketing our systems there. I think that the Brazilian market for our system is amazing. And also you can get low cost power usually at night because you have a lot of hydro and a lot of biomass for sure. And I wanted to say earlier, no one cuts good trees from a forest, shred them, and turns them into biomass. You always have wood chips, you have waste, you are doing deforestation you are taking care of a forest, not in terms of cutting off the forest You have a lot of agriculture. In agriculture, you have agricultural waste. So no one burns good commodity. You're always burning the waste. So it's a good thing to do. And biomass is not. Biomass is a huge source, and even the European, which are pretty strict, sees it as a clean fuel for the next 20, 30 years.
Hey, everybody. Thanks for listening to the Clean Power Hour or viewing it on YouTube. We do have a great YouTube channel. If you're not subscribed, please go to cleanpower.group and hit that YouTube icon and subscribe to our channel. Of course, you can find all of our content on your favorite audio platform as well. So please give us a rating and a review. Back to the show. I and Mark Jacobson, who's a professor at Stanford University, disagree, but that's okay. I would rather use biomass than fossil fuels, but I think that we need to aim higher. So, but that's neither here nor there. I want to, perhaps, if there's one more short thing you want to say about the industrial side of the house, that's great. But I want to dive into the grid energy side, or the power plant side of your technology, because that's something that I'm also very excited and interested about.
Yeah, I think that just let's the industrial is a universe of temperatures. You have cement and steel melting at very high temperatures. You have hot water at very low temperatures. We are taking the Pareto approach. We are doing all the way from hot water to very hot but not super hot steam or air, because 80% of the industry is there, and it's easier and more economical to deal with it. You have many young companies that are trying to take, to cherry pick the very ultra high temperatures. We do have a long term plan, and we have R&D, and we have second generation coming that will deal with these temperatures, but we are aiming to the mainstream of the industrial processes. And now I'm all yours with the utility scale projects.
Okay, great. So, I know that you and I have talked about peaker plants. Any kind of a thermal power plant can leverage your technology at face value, right? And then just a matter of scale. Power plants come in all shapes and sizes, from, say, perhaps as small as a megawatt to upwards of 1,000 megawatts or a gigawatt, or even multiples of gigawatts. But what is the target market, and where are you getting traction?
Yep. 90% of the power generated is generated through a thermal process today. And it's not going to change dramatically in the upcoming, I don't want to say the number because it doesn't matter, but many years. And we are able to provide this flexibility to fossil power plants, either gas or coal or nuclear, because now, as I mentioned earlier, they are usually running flat. This is what they were built to run flat, to provide baseload. And when you have high penetration of renewables, and I will demonstrate it through our power plant, not but our project in Italy that we have partnered with Enel, the Italian utility. It's Europe's largest utility. And in Italy, you have a spot market, same like many countries in the US, every 30 minutes. So, and you have almost 40% of solar in the grid. So in a nice day, at 9, 10 a.m., a grid operator asks this power plant, please go off the grid. We don't need you. Now, they don't have an on-off button that they can just pop, cool down their heat exchangers and close everything and go to sleep until 3 p.m. when the sun starts to go down, and then you have the all-known duck curve. They have to ramp up very fast. So bottom line, they cool down a little bit. They take their turbines a little, off the peak. They burn the same because they are not efficient when they are doing so. And at 3 p.m., they are all ready to come back and manufacture 100% of their capacity. But bottom line, you didn't save a single unit of carbon, and that's sad because you were paying for these guys all along the way for their availability, and now they are charging you with they are bidding for high prices because they have to, they have to get paid for what they did not sell earlier, and you were paying for the PV in parallel. So we are in a lose-lose situation. The energy prices, the power prices are going up. Carbon is not going down. And when you are incorporating a thermal storage into such a power plant, first, the efficiency is amazing. When you go to a university professor, he will say, but thermal storage, the efficiency is 40-50% tops, and a battery is 80%. But if we are in a stage before the electricity is being produced and we are just taking heat and bringing heat back, then our efficiency is around 90%, which is amazing. So we are taking excess heat and we are keeping it, and we will provide it back to the plant at 3 p.m. Thus, we were saving all the gas that will go to waste. Also, we will enable the plant to provide grid balancing to his own assets, the Enel assets, for example, at night. So in the future, they will be able to provide themselves grid balancing services to their wind farms, right? Heat the storage with this excess wind power at night, and in the morning, burn less gas or not burn gas at all. Run the turbines on the heat we collected last night. Also, clouds come in, it's midday. We will enable them to ramp up in minutes because we are a heat exchanger and we are always hot, and we can ramp up the power plant in minutes, so they can play inside the 30 minutes bid system, inside the S&P, and they can actually earn more money, and they can provide the power when it's needed. So you need less speakers. It's an amazing solution. We are starting with this combined cycle, and then we will have a very big and important reference site to show all the rest of the utilities, and that's quite a conservative, space, power plants, utilities. So being the first one with this utility scale demonstration site is very important for us as a company, as a technology. So we are fully commercial on the industrial scale. We're pre-commercial in these utility scale projects. We can build them all the way to gigawatt scale in one site. You cannot do that with batteries. And our land signature, the amount of land we need is around 1/10 of batteries, because we can stack them up, right? We can go high. We don't need to cool down. We don't need to have ACs for the system. And our lifespan, by the way, is endless. We are riding 30 years because you have to put some number, but nothing there to deteriorate. So and all materials are eco-friendly, no hazardous material. From cradle to cradle, we can source materials locally, we can manufacture locally, which I think is very important, especially for the US market, and especially with the current bill that just passed, a couple of days ago, that gives a lot of weight to local manufacturing. So we do plan to manufacture locally on every location. We have a significant pipeline. So you can see Brazil, we have a factory, it's a gigafactory, being ramped up now in Israel, and I'm sure and positive that many will follow on the target markets.
So you've got a combined cycle, let's just say natural gas fired power plant. You're bolting on Brenmiller technology. And I looked at the white paper on your website or the brochure, and it shows how the BGen unit helps the plant ramp faster.
Yeah.
Walk us through how, at the end of the day, kind of before and after, a Brenmiller approach or solution is going to help decarbonize a combined cycle power plant.
Great. And maybe let's start with a coal power plant because it's simpler to understand. Combined cycle is two turbines and heat recovery. And when you go to a coal power plant, so you have coal, you have a burner. This burner produces hot gases. They are heat exchanged to steam, and then this steam runs a turbine, and then you cool it off, and you have a cycle. We can and will replace the gas burner, the coal burner, with our system. So you will take excess wind power at night, hit the system, and then we will generate steam directly to the turbine. Now you are just cookie cutting the coal burner. By the way, in case of emergency, you can keep, a small mountain of coal for a rainy day, and once in a couple of years, run the plant in case of emergency on coal. That's okay, because I think that making sure you'll get energy it's a top priority. And let's talk about Texas, a couple of years ago. And now you have all the turbines in place. You have so many coal decommissioned in a year in the US. So you are keeping the jobs, you are keeping the same facility, grid connection, turbines, water treatment, everything except the burning of the coal. With our system, you hit a system with wind power at night, so we are also providing another service, which is grid balancing to the curtailed wind. Think about Texas, for example. And now you have a huge green peaker that runs on less night wind, and really in case of total emergency, once in a few years, you run it a couple of days on coal if you need it, if you don't have, other sources. So that's a very important and interesting exercise. The issue with coal is that for new technology, it will take us some time, to go all the way to meet these huge sizes. We are now in discussions with a plant sizing 2 gigawatts. So 2 gigawatts, you take 8 hours of storage, you have 16 gigawatt hour storage at one location. That's pretty huge. So that's the only, I would say, hurdle to retrofit coal power plants, in matter of just taking it a step at a time. So for gas fired, you have the gas engine. Then the gas engine is pretty flexible. And now you take the heat from the exhaust of this gas engine, you convert it into steam, and then you run another steam turbine. We're standing in the middle between these two turbines. Now, if you have a 100 megawatt engine and a 50 megawatt steam, and you have a 150 megawatt power plant, we are now providing the flexibility to run just the 100 megawatt, take all the excess heat for later. You can run on partial load, the 100 megawatt. Now, on peak demand, you can do more than 150 because you have some room left usually on your steam turbine. So you can have like a green shoe, take more than 150 for the power plant, and you are not wasting heat, cooling off, ramping up. When you are ramping up a power plant, a gas-fired power plant, the heat exchanger is your main concern. It takes time to heat them up and to cool them down. Now we are a very, I would say, sturdy and we are always hot. So we can provide the steam really in an on-off scenario, thus providing this power plant. It takes a normal gas-fired power plant 4 hours sometimes to ramp up, 4 hours to cool down. So if at 10 a.m. he needs to cool down and at 3 p.m. he needs to ramp up, that's exactly 8 hour cycle, in a day. So we will enable them to ramp up and cool down and get off at really in minutes. I hope it's clear because it's really fast on something very complex.
Yes, I agree. These machines are fairly complicated, but the long and short of it is that you could take a coal plant and largely replace it with Brenmiller units running on clean electricity, right?
Yep.
And then using traditional steam turbines to make electricity, right, on demand.
Second life to coal power plants.
Yeah.
You just throw away the burners and the conveyors that brings the coal in, and you take off-peak hour electricity. Absolutely.
And then in a combined cycle plant, you're leveraging the waste heat from say a gas turbine, right? Which is kind of a jet engine, isn't it? That's
Exactly.
taking heat and converting it to mechanical energy directly and making electricity with it. And then the Brenmiller unit can be used to capture some of that waste heat and then reuse it to help that machine ramp faster. Is that the basic concept there?
Yeah, and also take off-grid power at night. So you have, and then, by the way, a lot of time you have low-grade heat that goes to waste, and now you can just, boil it a little bit and bring it back. So bottom line, efficiency and flexibility and dispatchability, all in top-notch, new, even combined cycles, enabling now more renewables into the grid because you have a power plant that you can work with, and not just I have, as a grid manager, you can push more renewables because you can shut down these power plants very fast or call them back again very fast if the wind goes off or you have some clouds coming in. And bottom line, you need less reserve over your grid. You can be more efficient over your grid management as well. I see what's going on here today, by the way, in our grid. So on high peak hours, you have 10% reserve over the grid. When the sun shines and you have a lot of PV, you go above 30%. Now, all these 20% is energy that we generated just, we didn't have to. So it's pollution. The taxpayer pays it, and that's just said. We need technologies like our technology that will enable a leaner and more efficient management of the grid.
Yeah. So for all my renewable energy professionals who are listeners of the show, when you're having conversations about the grid and people say, well, wind and solar are intermittent, so they're not a solution, the retort is, well, that is true. They have to be paired with storage like Brenmiller units, which captures renewable energy and then gives it back to you 24/7 potentially. And so that is what is so wonderful about this explosion in thermal technologies that we now see, that we have a solution for long-term storage, for thermal heat, for grid power that pairs so nicely with excess wind and solar or hydro or wave energy or whatever renewable source you have access to. So in our last few minutes together, Nir, how can our listeners reach Brenmiller, reach you, and then I will also make just one or two quick announcements.
Perfect. So we have an active website. You can go into our website and contact through. We are on LinkedIn. We are available to you. I will send you my email and you can attach it as well. And we look forward to have discussions with anyone. We are very busy, but we are always busy for more. and I really appreciate the time and opportunity. I think that you need a lot of solutions. You need thermal, you need chemistry, you need flywheels, you need pumped hydro. It's like transportation. You don't use just bicycles or cars. You need the whole variety of solutions, bottom line, to bring clean sources that are intermittent to replace the way we generate energy today. And we are on the right pathway, I believe.
Please check out all of our content at cleanpowerhour.com. Please subscribe to the YouTube channel. If you're interested in sponsoring this show, we are looking for corporate sponsors. So if you are a manufacturer, if you make equipment for solar, wind, or energy storage, please reach out to me. I'm TG Montague at Gmail. I'm TG Montague on Twitter. And of course, you can contact me via the website as well, cleanpowerhour.com. With that, I want to thank you, Nir Brenmiller of Brenmiller Energy, for coming on the show. I'm Tim Montague. Let's grow solar and storage. Take care, Bren. Sorry, Nir.
Thank you. It's okay. Bye-bye.